So 13. In previous lessons, oh yeah, well 1 and 2. Hurry up, Brandon.
I'm coming. I'm just grabbing a calculator. Let's do it.
Can you pass me mine? Nothing. Alright. So you do 1 and 2 to your own discretion.
Number 3.
3, I said we assume that the standard deviation is unknown. Is that right?
Yeah.
Not now.
What the freak's going on?
That was loud. I think we end up using the D.
My phone. Okay. So.
This lesson we assumed the population standard deviation sigma was known. In this lesson, we're making a different assumption about sigma. What has changed? We assume sigma is unknown.
Yep.
Agreed.
Okay. The null hypothesis is ho, u equals 8. If the alternate hypothesis is that equation, then the population standard deviation sigma is not known. Convenient. Brooke collects a sample size of 9 and computes x bar is 11 as s is 6. Use this information for questions 4 and 5. Is sigma known? No. Oh, it just said that. That's some solid questions. It's probably going to be yes, and we're going to.
I was about to say they're going to be like marked wrong or something like that.
I'll be like, LOL, I tricked you. All right, what's the value of t? I gotta look up the equation.
X bar minus the mean over s divided by the square root of n.
Oh, it's pretty much the same.
It's just 3 divided by 2? 1.5.
So 11 minus u. Wait, we don't have u. Oh, it's 8. Divided by. So I gotta work it out, or I'll never remember what to do.
You got 1.5.
Yep, that's what I got.
6 divided by root 9. 1.5? Is that what we said?
Mm-hmm.
Yippee skippy. Alright, so I plugged my stuff into SPSS, and are we doing the one sample t-test right now? Okay, so plug in, explore, analyze, descriptive statistics, explore, temperatures.
Okay. What is next?
Did you guys open SPSS?
Yes. Brandon,
Okay.
you can't, right? Or can you?
No, I can't on this one.
Do we need to change anything for temperatures when we put it in the dependent list?
I didn't.
I don't think so.
Oh wait, I'm totally wrong. Hang on. Oh, retard. Analyze, compare means. One sample t-test. So wait, we don't put in a test value right now? Or change our confidence interval?
I don't think so.
Are we at 95 still? I'm going to assume we are.
Yeah, because it's the alpha is 0.05. Wait, no. Yeah.
Yeah, so 95. Test value, is that what we plugged in? Or no? I was just watching the videos and I can't remember what he said.
I don't remember.
Whatever. Let's go with it. Alright, the X bar. That's the mean, right?
Mm-hmm.
So I got 98.22.
Yeah, that's what I see. 98.220.
Right?
Kind of high. Nah.
Hang on. All right, I think you're good. What'd you say?
Nothing. We're good.
What was it on that one?
Yeah.
98.220.
Good eats. All right. S stands for, what was that? Sample size, right? Nope. Shoot, what is S again? S, standard deviation. Okay, standard deviation is 0.922.
Yep.
Sorry, I'm just trying to remember the stupid letters. I mean, my favorite letters.
The T score was 476.407.
Yep. And then the
And the
p-value, is that the 0.000? Because it's already 0 and you can't divide it by 2. If you were doing a single.
The p-value is equal to sig two-tailed.
Yeah, so it's 0.000.
Yep.
If it was a one-tailed, he said, but since it's already 0.
All right.
Okay. So p-value. So if the p is low, reject the null. That's how that quote goes.
So 10 is reject the null. Okay.
Should be.
Oh, copy these ones.
If not, I quit.
Okay, paste.
All right. Analyze, compare means, one sample t again, correct?
Yep.
Are we still at 0.05 or whatever?
This one doesn't really say.
The first, well, it kind of says that the first question is like a level of significance of 0.01, so we're at 99 this time.
Oh.
So go to
You
your
want to
options. Go to options when you put in the temperatures and then confidence interval percentage 99%.
Options.
So wait.
What?
Hang on, I'm gonna watch this part of the video real quick because this is gonna come up later, I'm sure, in the homework.
Hello? Good. Can I call you back in just a little bit? I'm in a group project.
So test value, you put in the null hypothesis.
Okay. Bye. I'm sorry, what?
Or did it have one? Yes, no, maybe so.
Well, wait. Are we changing it to 99% then?
Well, no, I'm saying going back to question like 6 through whatever.
Yeah.
Because on the video, hang on, I'll repeat exactly what he says. Give me a sec. So one sample T. If you're doing a hypothesis test, you have to put the null hypothesis in the test value. So you plug that in, and then you go to options, and then that would still be 95. So we need to put the null hypothesis, which was
98.6.
yeah. So I'm gonna replug those in real quick. Hang on. See if we get a whole bunch of other numbers. Control copy, control paste, analyze, compare means, one sample t-test, options, one was 95%. And what was our null hypothesis? 98.6?
Yeah.
Okay. So
Where are we putting
looking
that?
at my
In the test value, wouldn't you put 0.05?
no, that's our alpha something else, level of significance.
Oh.
So in the test value, you put in the 98.6, make sure it's a 95% interval thing because of the level of significance. Hit OK. So our mean is still the same. Our S, which was standard deviation, is still the same.
The t-score is completely different.
Yeah, it totally changes. That's why I was confused. I was like, 400 and something degrees? That's too much or whatever.
Yeah, but now it's negative. Can our t-score be negative? Yeah, I guess it could.
Yeah, so now it's negative 1.843.
Mm-hmm. And our,
What?
it's negative 1.843. And our p-value would be 0.081.
Yeah. And so now we're actually higher than the null hypothesis, so we would fail to reject.
Mm-hmm.
Go back.
That could be really bad. Does that make more sense?
Yeah, it makes way more sense.
Okay. Because I was like, I know there's something in the video we're missing, and there it was.
That's what I thought too, but I didn't know if it was like me or. Okay, so for the next one, we're doing 99%.
Yeah, so we go analyze, compare means, one sample t, option, and what's our hypothesis?
40?
Just 40?
I think so, yeah.
Okay, yeah, I
That's all
think.
it says.
All right, cool. Well, there's our information again. We'll wait for Brandon.
Yeah.
Pardon.
P-value is 0.995.
Hang on.
Is
P-value.
it?
What did we put the last one? P-value. Oh. P-value's the. What the heck? Oh, there's a second t-test.
Where?
The last one. Okay, sorry. What'd you say?
Really? Are we doing for the? Is it the two-tailed?
Yeah, it should be. So p-value is the two-tail answer, which happens to be 0.995.
Okay, so sorry, I just came back.
Sorry, we already turned it in, dude.
Just one thing that I'm kind of curious about. Maybe you can explain this to me real quick. It talks about the p-values for those for the sig2 tailed section, and it's based off like the alternative hypothesis. So it says like what is the p-value, and if you go down, and if the alternative hypothesis is that it's in this case less than 98.6. It says the p-value is the area in the tail to the right of the or to the left of the test statistic t. You use sig two-tailed section, which gives you the area in both tails, then adjust it so that you get the area to the left. Usually this means you simply divide sig two-tailed by 2.
Oh.
So we have to divide that sig two-tailed section by 2 since all of our alternative is just to the left.
Okay.
So it'd be 0.498.
So
The p-value.
Does that apply to the?
I think it applies to the last one too, doesn't it?
That
I was
was
gonna say, does that apply to number 9 or no?
yeah. That's the one I was on. 'Cause I missed a few seconds. It was
So 041.
yeah.
Okay. So now since it's below again, now we reject the null.
Yep.
Okay, cool.
Okay, so you have to fill me on like 11, 12, or whatever else you've done.
Or we just went to 11.
Yeah.
So since it's a one-tailed test, do we divide it again?
All right. So for that one, our alternative is that guy says the p-value is the area of the two tails beyond the test statistic, so it's equal to sig two-tailed for that one.
Okay, so real quick, how do you know the difference between the two?
So if it's not equal to, you're going to take both sides of the two-tailed.
So it's just whatever it shows on SPSS.
Say that one more time.
Is that what shows on what SPSS says?
Yeah, that's going to be the two-tailed.
Yes, that's the one. That's the sig two-tailed section.
Okay.
And then if you have the less than or greater than, you just take that and divide it by 2 because it's only one side of that.
Oh, okay. So all you really need to look for is the not equal to, and that'll tell you if you divide or not. Everything else is pretty much just what it says.
Exactly.
Oh, cool. So this one we leave the same.
So what was that one?
Yeah, this one is 0.9.
0.995. Too many nines.
So we are going to fail to reject.
What was our level of significance? 0.01?
Yeah.
Yeah, definitely.
So we just keep it at the 95% confidence interval, and then we just use the sig two-tailed section to get p, and that's how we reject with the level of significance, right?
Well, for 11, we switched it to 99% because the level of significance is 0.01.
Yeah.
Does that change the level, the confidence level?
It should, because it'll make it like a bigger number. I don't know if that made sense. I don't know if that makes sense.
Like all the examples are for like 0.05 level of significance. I just don't see anything that says that we change it.
Well, just because 11 says you use a level of significance of 0.01.
Isn't that all we do for that is we compare the p-values, isn't it?
Dang, dude, I don't know.
I thought that's all that was for, is like that's your basis for your p-value for rejecting and accepting the null. I don't know that it changes our level or our other thing, confidence interval.
I'm going to watch that video again if you guys keep looking through the textbook.
Yeah, I'm reading through that textbook right now.
So Google says that 0.01 is 99%.
I believe Google.
Just saying.
I don't know. That makes sense to me. But I can see where you're coming with why would we change it.
Yeah, I'm fine with it if that's right. I just wanted to know why, because I have no idea.
Because isn't the level of significance pretty much with this? What is that we changed? Level of significance go hand in hand with our confidence interval,
Yeah.
or no? What did your thing that you read say, Brooke?
Well, the last two things I read said basically 95% confidence interval will lead to the p-value of point, or I guess the confidence interval. It's going to be 0.05, and the 99% is 0.01. Those are the last two things I've looked at that have said that, but I don't know. Trying to see.
Oh, no, I'm still trying to read through the homework stuff. Man, I don't know. I got nothing. So you guys just want to go with it and see what we learn?
I can't find anything that says anything otherwise.
Yeah.
Everything in the textbook's using 95, but it doesn't explain anything about changing it. So.
But everything I've read, every 99% is related to a 0.01, so I don't know if that means something or that's just everything I've looked at.
It's a big old coincidence.
Maybe. So 13?
So isn't this we just divide it by 2? Because isn't it going to decrease, and then we'll reject the null because it's 0.4 or something? Yeah, 0.49. Well, I don't know. Do you round up?
For 13?
Yeah. So
Yes. Divide that by 2.
yeah, and so it gives you 0.497 or something.
Yeah.
So obviously it decreases, but or is that an exact number?
You're asking what for 13?
Well, 13 I understand, but 14. So since it is 0.497, would we round up to make it 0.5?
0.497. I would say we would still keep it at 0.497, but even compared to our
0.498.
Oh wait, our level is 0.01. What am I talking
it doesn't
about?
matter either way.
Yeah, we're still way above it. Freaking on drugs over here.
Okay, yeah, I kind of see what's going on now. Okay.
So we still fail to reject.
99 and 13. Which one is wider?
Wouldn't it be the one with the greater confidence interval?
Yeah.
Oh wait, 11 and 13. Aren't they the same then?
Well,
because they're both 99%. All that changed was their what their alternative hypothesis. Whoa, computer, don't restart right now. What do you guys think?
I think they might be the same, but I'm not positive.
11 and 13, the only thing that changes is the confidence
hypothesis.
is the same, but the p-value is the only thing that should change when you change the alternative hypothesis.
Right, and
Yeah.
so that's not changing any of the tails or the freaking whatever the shape is called, the bell curve. That doesn't do anything. Right?
Yeah, I'd say they're still the same.
Is there anything in the homework that mentioned that? Okay, so compare the width of the confidence interval. It'd be the same. It'd have to be. Is there a way to make a bar graph on here? Or a bell curve thing on SPSS?
I think so, but don't ask me how. Transform. No.
Transform into data.
Graphs. There's a bar graph, a line graph, a box plot, scatter, histogram.
Oh, 100%. I mean, get in my group.
We didn't even go over the answers.
Oh, whoops. Well, they're all right. I'll go over them. I know them. After so much, I'm just like, oh, well, I'm just going to hit submit. All right, you guys ready?
Yep.
Yeah.
Well, we should be on the same page anyway because nothing's changed. So 1 and 2 are true. 3 is we assume sigma is unknown. 4 is no. 5 is 1.5. 6 is 98.220. 7 is 0.922. 8 is negative 1.843. 9 is 0.041. 10 is reject the null. 11 is 0.995. 12 is fail to reject. 13 is decrease. 14 is fail to reject. And 15 is they're the same. A+.
Sweetness.
All right.
Sorry, guys.
Okay.
You're fine.
It's only fine